Swayam Prabha. Digital India. Educated India.
Welcome back dear students to this course on architectural thesis. My name is Dr. Vishal Chettry and I am working as an assistant professor in the Department of Architecture, Planning and Design at IIT Varanasi. So in this presentation we will focus on the details about 3D views, renders and digital simulations. So before we proceed, we will try to cover what was learnt in the previous presentation through recap. Then we will understand what is actually a 3D view, render and digital simulation, because at times these may sound similar, but what is the actual difference between these terms, we will try to understand that. Role of 3D perspectives in communicating space and form, overview of rendering tools like SketchUp, Lumion, Enscape, contextualizing 3D views with people, landscape and light, why is it necessary, and how does these elements help you in improving the quality of your 3D views or renders or simulations. So that will be understood. Simulating real-time design environments and climate response, that will be also covered. Then there will be the conclusion of this presentation along with some wrap-up activities for your work that you can do after the presentation is over. Then some resources will be shown to you from where you can explore further about the topics, and then the details about the several aspects of the next presentation will be covered. So to give you a recap of what was covered in the previous presentation, we try to understand different types of details about the physical model. So physical model generally it provides a tangible and a three-dimensional representation that communicates spatial concept, materials and design intent. Conceptual, site and detail models convey different stages of design development, and they are very much essential at different stages of design. So when you are about to start, so possibly conceptual model may be the best one to explain the design idea. Then as you progress in your architectural thesis or in your design, then the detail model or site model may be relevant at those stages. Materials such as foam, cardboard, wood and acrylic are selected based on the purpose or the detail that you want to showcase, the scale that you want that you have selected for the project, and at which stage are you actually showing the model. So based on these factors, the materials are chosen for model. Model making techniques aim to accurately represent the design intent. It is effective very much effective to display and photograph is necessary, because effective display and photograph is not there, then there are chances that the model that you have prepared may not be effective to communicate the idea to the user or to a client or maybe to the examiner. So now let us look into the topic that we will cover in this presentation, that is 3D view first, then we will look into render and digital simulation. So what is 3D view? That is it is also called as 3D visualization. It is a process of creating three-dimensional representation of architectural design before the construction, so that whoever is the client or whoever is the user, they can visualize how does the structure that is designed for them will look like when it is completed or when it is executed on the ground. So that is basically the purpose behind preparing 3D visualization. So how it will look like has several connotations behind it. So first and foremost is the aesthetic of the structure. Next is its the different materials that is used. How does it behave, or how does it look like in a real life scenario or with real context behind it. So that is also understood. And when it comes to its interaction with the nature, so how does it appear in that context. So that is also why this is necessary, along with the form or scale of the structure. So that is also visualized in through your 3D visualization drawings. So the importance and relevance of 3D visualization is that it acts as a bridge between conceptual thinking and the physical form, because it helps architects test ideas and communicate them visually to their user group, allows real-time spatial assessment like scale, volume, proportion, material and atmosphere. All these details can be understood very clearly through the 3D visualization that you have prepared. Then it helps you identify the design flaws at very early, enabling rapid corrections. So at times when you draw the elevation, you are not able to perceive the flaws at that stage. So once you prepare the 3D view, possibly when you render it and when you see the real life picture, then at that time you will be surprised to see some design flaw that may have occurred while preparing the elevation of the structure. So that is where you have to go back, correct the elevation, or maybe to correct the elevation you may have to correct the floor plan also. So these are all a process that is generally adopted when you will proceed in your architectural design projects. So it improves decision making through visualization of structure, light, material interaction. So how does structure, light and material interact with each other? So that is what is clearly understood through 3D views. The 3D views that you prepare will assist in visualizing the volumetric relationship. That is, it will help you understand how different spaces connect and flow into each other. So that is a very good thing to be understood at a very early stage before it is completed, rather than once the building is completed, because at times floor plan communicate most of things to the user group, but then also to visualize it in 3D you require the help of 3D views. So that is why this is essential. And then it clarifies spatial hierarchy and orientation. It demonstrates the human scale and usability, allows assessment of comfort, openness and enclosure. It easily compares large public spaces versus intimate interiors. 3D views also assist in illustrating the design intent like atmosphere, emotion, texture and material quality. So all these are showcased through 3D views very easily. Light, shadow and mood creates the storytelling opportunity. So in case if you have any idea behind designing a space, a gallery or a corridor or an atrium in such a way that there are some ideas behind that, then possibly through 3D views you can show them that okay, during such and such day the structure may look like this, or it may create some interesting pattern inside the structure that you cannot possibly show through your elevation or through all those 2D drawings. You may produce some sketches here and there, but then sketches won't give you a glimpse of the entire structure. It may provide you some final details at some of small locations of the structure here and there, but when you prepare the 3D view, possibly there the entire structure can be visualized. At the same time the feature or the special feature that you have incorporated in the design can be understood very clearly. Communicating the structural complexity, that is geometry, layering and framing strategies, can be read very clearly through 3D views. Also, it assists in combining technical and emotional experience, not just how it works, that is not just the structural details of the structure, but also how would user feel about that project. The thing that I mentioned just before, if you have incorporated something very interesting feature and which is very seasonal or which may be experienced at certain locations or at certain time of the day only, so then possibly you can visualize that through a 3D view and showcase it to your clients or to your user group. supporting critique and review, because jurors, teachers or clients, after they see the 3D view, possibly they can further give you some comments which can be more helpful for you to incorporate. Then now let us look into the several rendering tools that we generally use for our architectural design projects. So first is your SketchUp. So it is very widely used, that is Google SketchUp, which is very widely used for fast 3D modeling and visualization. It is easy to work, easy to learn, ideal for massing conceptual models. There are numerous tutorials available in several platforms, so you can just explore those tutorials and try to start working on it as soon as you reach third year or even in the fourth semester of your architectural curriculum. So you can explore this model to use to use such kind of softwares to visualize your design, so that when you reach at your thesis stage, you are very proficient with the software and you can come up with very interesting design after exploring further the software. Then you can also use the plugin library that it has that the software has, like V-Ray, Enscape and others, which can help you render the model very effectively. It is compatible with Google Earth for contextual modeling. The strength of this software is that it is quick ideation. It is not a very heavy software, and you can quickly work around with this software. It provides visual clarity at early design stages to you as well as to your supervisor. The next is Lumion, that is it is a real-time rendering tool with vast material and object libraries. It adds dynamic elements like trees, water, animated people and wind, and it also adds movement to your design, to your presentation. Excellent for landscape integration and cinematic animation. Strength of this software is that it produces high quality outputs for client presentation and marketing. But to have such kind of softwares in your computer or in your laptop, your configuration has to be has to support this kind of software to run very smoothly. Then next is Enscape, that is it is a plugin based real-time rendering for Revit, SketchUp, Rhino, ArchiCAD, supports virtual reality and real-time navigation. It syncs live with the design updates. The strength of this software is that the real-time design feedback can be received and it provides a very immersive experience. Then next is V-Ray. It is the industry standard renderer for high-end photorealism. It produces fine control or has fine control over the reflections, refraction, lighting and texture. It has longer rendering time but extremely detailed output. The strength of this software is that it produces professional quality images for presentation and for publications. Then next is Twinmotion. It is powered by Unreal Engine, real-time rendering and immersive features. It has drag and drop materiality, lighting, seasonal changes, traffic flow. All this is possible through Twinmotion. The strength of this software is that it is ideal for urban design and environmental animation to be included in your project. Then next is Unreal Engine. It is a game engine adapted for architectural visualization, enables hyper realistic renders, cinematic walkthroughs and also for virtual reality. The strength is that it provides fully immersive storytelling and experiential design. Then to add context to your 3D views, you always it is suggested that you should incorporate people, landscape and light element into your render. So that is why these things are necessary, because it adds realism, it gives a scale to the structure. So visualize that in this image, if there is no natural light that is allowed to enter and there are no humans or no vegetation, just the structure. So at times, though you may be able to understand the material, but how does this material interact with the people, are they comfortable using it, or you should go for some other material. So all that can be thought of if you incorporate these elements. So you have a staircase here, and it may so happen that you have not incorporated any lifts or any ramp in a structure, and you have a you have a user group like a lady with her kid, or a man with his kid, along with some physically challenged or visually impaired person. But then at times you may forget about all these different user groups when you design. But if you add these different types of users in your design, especially in your 3D views, then you may reflect on the issues, like you should have thought for ramps, you should have thought for incorporating lifts into your design, so that all different user groups are addressed, or your design is more inclusive in nature. So use diverse inclusive figures. So that is why it is necessary. It helps viewers relate personally to the design. It suggests the movement pattern, walking, resting and interacting. So at times you may forget to incorporate resting spaces in your in and around the atrium, or in and around the common spaces. So possibly there at that stage you may think of incorporating some resting spaces, or the width of the corridor may not be sufficient when 2 or 3 people are working together. So then you may have to go back to your floor plan, then do the changes as required. Also if you incorporate these elements, it emphasizes circulation, gathering spaces and transitional zones. So how these zones, which often are neglected, we just provide 2 to 3 meter width of corridor and that's it, we don't detail out these spaces. But when you incorporate, when you start preparing 3D views, possibly then these things might click, and then you incorporate it in your floor plan as well. Then next is landscape design. So in this, incorporate terrain, vegetation, water bodies and built surroundings as shown in this example. So if you are thinking that your structure will not be visible on ground, but it is entirely below the ground, so then you have to provide all the landscape elements that are necessary. Or if you are thinking of having some green roof on, like as on your structure, so then possibly you should provide all the landscape elements in your roof, so that the green roof is visually connected to the user, and also it can be understood very clearly that how does these elements relate in real life. Then it indicates ecological sensitivity and site adaptability, that how your building will adapt to the existing condition. Seasonal elements show building character throughout the year. So that is also important to understand, that how your building reacts during monsoon, during summer or during winter, or even in autumn season. So that is why these elements are necessary to be integrated. Then next is the light element, that is natural and artificial. Natural, that is during daylight condition, light direction, intensity and color temperature influences the perception. It simulates atmosphere, that is warm morning glow versus cold overcast features. So how does your structure react to this situation and these circumstances that can be showcased. Shadows communicate depth and texture. Interior lighting impacts comfort, usability and visual appeal. So that can also be understood. Useful for night renders, emphasizing facade lighting and transparency. All these elements can be incorporated in your 3D view, so that these are also evenly focused by the client after the construction of the structure. Then simulating the real-time design environment in climate response. So for this we go for real-time walkthroughs and VR. So Enscape, Twinmotion and Unreal Engine allows real-time movement through space. It supports VR integration for immersive presentation. It helps to detect the circulation issues and scale mismatches. It is valuable for design critique and user feedback sessions. Then next is your sun path and shadow studies. This is very important, so that your building is climate responsive. So to analyze building performance during different times and season, it is essential. It optimizes shading devices, window sizes and building orientation, prevents overheating or prevents creation of dark spots in your facade or within the structure. It helps position solar panels and light wells effectively through this analysis. Then next is your daylight analysis. Tools such as Ladybug, Honeybee, Diva for Rhino, Revit plugins are necessary for daylight analysis. It simulates daylight levels in interior, evaluates daylight autonomy, glare and spatial brightness, improves the productivity and user comfort within the workspaces and home. So this sort of analysis is also very important. You understand where is the dark spot, where there is too much light or too much glare that is coming inside the structure, and then you design your fenestration or shading devices accordingly, or even you position your windows in your structure accordingly. So these analysis helps you in deciding all these elements. The next is thermal and energy simulation. Tools like Ladybug, Honeybee and similar plugins are required for such analysis. It simulates daylight level in interiors. It evaluates daylight autonomy, glare and spatial brightness, improves the productivity and user comfort inside the workplaces. Next is rainwater and wind simulation. This is essential especially for structures that are located in regions where there is heavy rainfall or there is very strong winds that come generally experienced in that region. So you may have to simulate such conditions, design implications for sloped roof, drainage or facade detailing, what sort of facade has to be there in such cases. So the plastering, the details about plaster, details about exterior elements, all that has to be decided based on this analysis. It ensures that the building is durable and environmentally sensitive. After you perform this analysis, you will be able to take required decisions. Then to conclude this presentation, we have emphasized on the importance of 3D views, renders and digital simulations, as it provides immersive, realistic representation that brings architectural design to life. Because as already explained you before, only with the help of 2D drawings at times it is not possible for you to explain the details of the structure. So if you have 3D views, if you have all these like simulation or walkthroughs with you, possibly then the client or the examiner will be able to understand the certain nuances of your design. 3D perspectives effectively communicate spatial relationship and form, helping audiences better understand the design intent. Because your 2D drawings may communicate the details, like for example in your floor plan you may be able to explain us how this space that you have designed is effectively utilized, or or the space is optimum utilization of that space has happened. So that you can explain through your floor plan by looking into the furniture arrangement or by looking into the user movement inside the structure. But then to visualize it in real life, you need 3D views or animation to understand these things. So that is why 3D perspectives are essential. And at times some clients, they are not much proficient with architectural drawings like floor plan, elevation or section. So for them to understand, you require 3D views and perspectives for explanation, or even walkthroughs to explain the details. So that is why it helps you communicate your design idea to your client without any interference in between. So that is the major advantage of incorporating 3D views in your architectural submission. So popular rendering tools like SketchUp, Lumion and Landscape empower architects to create high quality visualization with diverse material and lighting effect. At times these tools help you sell your products also, because people are able to look into the structure, how it will look like in real life conditions. So so just by showing the floor plan or just by providing the elevation, people can't relate to to its real life scenario. So that is where these details are required. Contextualizing 3D views with people, landscape and lighting, as we do for your elevation or even in your section when you prepare all these drawings, you incorporate all these elements. So same idea is here is used here. You have to incorporate these elements so that context is provided to the design, and it situates design with the correct environment. Simulating real-time environment allows evaluation of design performance under varying climate condition and supports the informed decision-making process. So at the end of this presentation, you can perform some kind of wrap-up activities, like you can just recollect that have you ever seen a render that looked empty or unrealistic. So try to look further into that render that you have seen. So what was missing, you can now possibly pick up after this presentation is over, and try not to make the same mistake when you prepare the render for your submission. Will virtual reality replace physical site visits before construction? Does this question come up in your mind once after you have learned about the importance of virtual reality? So can this happen? Just try to think on this question. Then these are some resources that are provided which you can refer for your better understanding on the preparation of 3D views, renders and similar details. So in your next presentation, we will focus on walkthroughs. So we will understand what is exactly a walkthrough, and the final visual presentation related to walkthrough, what has to be introduced over there, and how it will impact the architectural your detailing or drawings. So that will be understood. Planning and scripting for walkthroughs, because that is essential, because it is a frame by frame work that is to be done in this case. Tools and workflow, utilizing software and techniques to create smooth, detailed animated presentation is required. Integrating into juries and digital submission is very essential in this case, because it effectively embeds walkthroughs in project reviews and in your own online portfolio. So that is why it is essential that you incorporate walkthroughs, because it it effectively enhances the work that you have done. Some tips for a impactful visual presentation is that it enhances the engagement and it provides clarity through the polished animation and presentation skills that you have developed through your this 4.5 years of learning. So with this, I'd like to conclude my presentation today, and I hope that the details about the things that have been covered in this presentation is very useful for you on while you prepare 3D views or render or even the simulation for your project. So I'd like to thank you for your patience listening.